The 400-ton methanol reactor was probably a breeze to install, standing alone in the middle of a paved draining area. But the years since had seen a lot of development at Valero Refinery in Delaware City, Delaware. A heat exchanger had been located as closely as possible to the reactor it served, and concrete structures had been erected on 3 of the reactor's 4 sides. Now the plant was to be decommissioned, beginning with the removal of the reactor to its new owners in Trinidad. Suddenly, the heat exchanger and concrete structures had a new name: obstructions. So tightly was the reactor ringed by obstructions that the use of cranes was quickly ruled out as a viable or cost-effective option. What was needed was a tower lifting system, specialized tailing equipment, and trunnion lift links. Exactly the kind owned, operated, and fabricated by Atlas Industrial Contractors of Columbus, Ohio. Lightweight, and needing only a relatively small assembly crane supplied by United Crane and Rigging of Baltimore, Maryland, the tower sections and header beam assemblies would rise to over 70 feet top elevation. The header configuration would be 2 W36 by 359 by 50-foot beams. The lifting would be done by 4 L100 PSC strand jacks, each with 108 metric ton capacity. For the tailing equipment, Atlas would employ 2 legs of its 500-ton lift system's hydraulic gantries, supporting a W38 by 475 by 50-foot header beam. As the tower lifting system raises the reactor, the gantry tailing equipment will provide the forward movement that will walk the bottom of the reactor away as the top moves through its rotation to horizontal, and the lowering process continues. At the same time, it will raise the reactor to keep the bottom away from the ground as the top is lowered. Then raise it to bring the entire reactor to elevation before lowering it into shipping saddles. As the top of the reactor is lowered, there will be only inches of clearance between it, the concrete structure immediately adjacent, and the reactor's heat exchanger and protruding nozzles. Engineered by Ruby & Associates of Farmington Hills, Michigan, an old and trusted colleague, those inches are all the assurance that Atlas requires. The schedule window for the project, which also includes the dismantling of the 100-ton heat exchanger, is 3 weeks from the date that equipment begins arriving on the site. With contract in hand, Atlas began designing and fabricating several needed components in its shop. Required were 2 180-ton trunnion links that would attach the reactor's trunnions to the strand jacks for lift and rotation. Also, a unique tailing fixture that would pass beneath and be welded to the reactor's skirt to accommodate Atlas's tailing equipment and reactor design loads, and a 100-ton lifting link that would attach the tailing fixture to D-rings on the 500-ton gantry's header beam. All rigging attachments and fixtures were designed with a safety factor of 5:1 to account for any unknown or unexpected variables. When these were complete, Atlas arrived on the job site and the clock began ticking. It was Monday, July 10, 2006. The first item of business was to assemble the gantry track. 2 45-foot sections of Atlas's 800-ton heavy-duty gantry track would act as the tower lifting system's base and be joined to an additional 30 feet of 400-ton gantry track to allow for a common runway for the tailing equipment. Because of the 6-inch difference in height of the rails, and because the whole of the track would pass over a bowl-shaped draining area, timbers were placed and shims employed to level the entire 75-foot length of the tower base and track. Then, too, engineering had determined that the best way to stabilize the lifting tower was to bolt its bases directly to the 800-ton gantry track sections. The timbers would also help to distribute the load from the tower more effectively. By Friday, July 21st, the reactor was lifted for the first time, 1 inch above the formidable foundation on which it rested. Atlas personnel quickly determined that the actual weight of the reactor was in excess of the estimated weight provided by the owner's drawings. The tailing fixture was then inserted beneath the reactor's skirt, and the reactor returned to its former position on its foundation and support cribbing as the lift entered a built-in hold point. The next morning, an engineering review was conducted to determine if the actual weight, 384-ton versus the anticipated 360-ton was still within engineering and safety parameters. It was, and a go was given to continue. On Monday, July 24th, the temperature climbed into triple digits as the reactor was once again raised from the foundation, and the Atlas crew, clad in fire-retardant Nomex jumpsuits, completed the full penetration welding of the tailing fixture to the reactor's skirt. Suddenly and unexpectedly, the job site was hammered by ground-burst winds. The lifting assembly and bracing had been engineered for maximum winds of 20 miles an hour. That afternoon, one gust was clocked at 55 miles an hour by the Valero weather station. Atlas returned the reactor to rest on the support cribbing and tailing fixture, and work was secured for the day. Tuesday, July 25th dawned hot and bright, with the temperature already at 99 degrees. At 7 a.m., the Atlas crew, engineering, and management team conducted a pre-lift safety and responsibility meeting. With all needed safety and lift communications in place, including a beam safe system, the Atlas team was ready to move forward. At 7:30, the lift resumed. The reactor was raised from its foundation for the last time. As it was raised, the tailing equipment moved slowly away from the base of the tower lifting system, keeping the vessel clear of the ground and slowly raising the bottom as the top was lowered and rotated to horizontal. During this critical time, the need to keep the reactor trunnions and tower legs in a plumb attitude was closely monitored by Atlas personnel using precision theodolite instruments. With an out-of-plumb tolerance of only 3 degrees, successful coordination between the tower system and tailing gantry operations required close communications between the various Atlas teams on the project. Once again, the temperature climbed into triple digits, and the strand jacks had to be stopped periodically to let the hydraulic oil cool before proceeding. By 1 p.m., the lift and rotation were complete, and the reactor lay securely in its saddles. Thanks to Atlas's project-specific site safety plan and close coordination with Valero's stringent safety requirements, the entire project was completed with 0 recordable injuries or lost day incidents. As a matter of fact, the lift had gone so smoothly that the grout finish on the outside of the reactor skirt hadn't as much as cracked. The entire project was completed within the schedule window with days to spare and resulted in a satisfied customer. Many companies have what it takes to perform the anticipated. Having the experience to manage the unexpected is what makes Atlas Industrial Contractors the contractor of choice for many of America's largest industrial corporations.